Look around you. Every device, every server, and every neural network powerhousing the AI revolution is built on a lie.
Beneath the code lies a physical reality. A bottleneck so narrow, it determines which nation wins the future.
They do not write AI models. They do not build data centers. Yet, without them, the entire global technology apparatus collapses into dust.
It is a machine of pure physics. So complex, so fragile, it shouldn't even work. But the most terrifying part is that
We are building a digital god, and its entire existence hangs on one company's ability to manipulate the impossible. Stay with me.
By the end of this video, you will not just understand a corporate monopoly. You will see the invisible system of glass, lasers, and geopolitics. We do this using a process called photolithography. Think of it like using a stencil and paint, but instead of paint, we use light.
But as AI demanded more power, the switches had to become smaller. And ASML spent 17 years and billions of dollars, failing, experimenting, and risking bankruptcy.
Why? Because EUV light is so fragile, it is absorbed by almost everything. It is absorbed by glass lenses. It is absorbed by the air.
Mirrors polished to an accuracy never before achieved by human hands. If a mirror from an ASML machine were scaled to the size of the United States, and ASML spent 17 years and billions of dollars, failing, experimenting, and risking bankruptcy.
First twist. And here's the twist. ASML doesn't actually build these machines alone. It's not just a Dutch creation.
A system that blasts a microscopic droplet of molten tin twice with a high-power laser, 50,000 times per second. The robotic arms and chemical resists come from Japan and the United States. ASML is the architect, the only entity on Earth capable of trades. Each machine contains over 100,000 parts, costs upwards of $150 million, and requires 3 cars. If this story is already showing you the hidden architecture of our world, perhaps it deserves a like. It helps the algorithm find others who want to see beneath the surface. TSMC in Taiwan, Intel in the US, Samsung in South Korea, they all wait in line. They beg ASML for these machines, which brings us to the core of the system, the geopolitical trap. Because this machine is so powerful, it has become a weapon.
To truly grasp how deep this rabbit hole goes, we must examine the hidden conflict playing out in the shadows of the global supply chain.
A modern semiconductor fab is not just a factory, it is a sovereign fortress. And because ASML is the sole gatekeeper, imagine a single entity that holds the veto power over the computational advancement of any nation. If the European Union wants to establish digital independence, they are bound to the production schedule in Veldhoven.
For the past decade, Beijing has poured hundreds of billions of dollars into its domestic semiconductor industry.
They could not build the extreme ultraviolet lithography machines, and they could not buy them either, because under pressure from Washington, the Dutch government intervened. It was a geopolitical chokehold. A single regulatory pen stroke did more to slow down China's technological expansion than years of... As the physical limits of silicon draw closer, the machines must become even larger, more complex, and vastly more expensive.
What is High-NA? It stands for high numerical aperture. In simple terms, it is the next step in the manipulation of light, allowing for even tighter focus and smaller transistors.
It now costs over $350 million per unit. It requires a completely redesigned optical system, mirrors that are even more...
Even a heavy truck driving a mile away from the factory could misalign the light beam and ruin a multi-million-dollar batch of silicon.
It is an environment cleaner than any operating room on the planet. And who can afford this?
This means that the entire future of human computing power is being concentrated into a tiny elite club.
But you can delete an app. You can switch search engines. You cannot switch the laws of physics. You cannot build a competitor to a machine.
But wait, there is another version of this story. One that highlights the extreme fragility of Veldhoven itself.
But inside ASML's clean rooms, workers wear full-body bunny suits, filtering out even the smallest speck of dust. And because these machines require constant maintenance and specialized spare parts that only ASML can provide, existing machines around the
This means the entire facility is a hyper-delicate bubble. If an earthquake, a major power grid failure, or a local industrial disaster were to strike this small region, prices for electronics would skyrocket. Cloud computing companies would struggle to replace failing servers, and the rapid expansion of artificial intelligence. We have built our entire digital future on a single geographic coordinate. It is a concentration of risk that like any risk and
But it isn't. It is a single thread. And science found that we are pushing that thread to its absolute breaking point.
If you thought the physical limits were the only obstacle, the financial reality will surprise you. To keep up with the laws of physics, the cost
ASML's biggest customers, TSMC, Intel, and Samsung, are not just buyers, they are co-investors.
This created a feedback loop where the rich get richer and the barrier to entry becomes impossible to climb.
They would need to secure hundreds of billions of dollars, build relationships with thousands of highly specialized suppliers, and convince the world's largest. But today, the Silicon Tower is highly centralized. We have traded competition for efficiency, and in doing so, we have built...
The truth is much worse. We have created a technological dictatorship where the rules of progress are written by a tiny handful.
But there is another hidden layer to this monopoly, the human supply chain. An EUV machine is not just steel and...
Tacit knowledge is the kind of expertise that cannot be written down in a manual. It is the feeling a Carl Zeiss technician has when adjusting a mirror alignment.
There are fewer than 500 people on Earth who fully understand how to calibrate and maintain these machines.
But these individuals are bound by strict non-disclosure agreements, non-compete clauses, and a deep loyalty to their company. It is a fortress of human capital. If you wanted to build a rival lithography company, you would have to rebuild an entire society of scientists.
In our modern, fast-paced world of software and rapid returns, that kind of long-term human dedication is incredibly rare.
We are living in a silent Cold War. On one side, the West, trying to maintain its technological edge.
And the United States has pressurized the Dutch government to block ASML from exporting its most advanced machines to China. But there is a final, hidden layer to this monopoly that no one is talking about. It is not just about who buys the machine.
As we push toward high-NA EUV, the next generation of machines, the cost is ballooning to $350 million per unit.
The monopoly is not just at the manufacturing level, it is centralizing the entire computational power of humanity into fewer and fewer hands. We are not just building AI.
And that is a fragile foundation for a civilization. What would you do if you realized the software you use every day?
The systems that run our world are designed to look robust, distributed, and global. But when you look beneath, you find they are held together.
It is a miracle of human engineering, a testament to what happens when we refuse to accept the limits of physics.
Which leaves us with a chilling question about our future. What happens when the thread snaps? In our next video, we will explore the secret cartel.
Subscribe to make sure you do not miss it. Thank you for looking beneath. But to understand how we got to this edge, we must look backward.
No one had heard of ASML. It was a tiny joint venture between Philips and ASM International, operating out of a leaky shed in Eindhoven.
They were trying to build systems that other, larger corporations dismissed as unnecessary. For years, Philips debates.
But a small group of visionary Dutch engineers refused to let it die. They believed that light could be bent and focused inwards.
They worked on a logic that seemed absurd to outsiders. In their minds, the risk was not failure, the risk was stopping.
By the time the industry realized what was happening, the head start was too wide to close. It was not a sudden victory. Now, fast forward to today. The complexity has scaled to a level that sounds like science fiction.
It is not a package you send in the mail. A single machine requires 250 massive shipping crates.
And once it arrives, it requires a team of dozens of highly specialized ASML engineers living on site for months just to assemble and calibrate the system.
And the clean room it sits in must be built with structural damping that can resist the vibrations of waves crashing against a shore 50 miles away.
If a single step in this logistical sequence is delayed, it costs the receiving chip maker millions of dollars, the dependence per day. This brings us to the geopolitical heart of the crisis, the TSMC triangle. TSMC, based in Taiwan, is...
But TSMC cannot build those chips without ASML's EUV machines. And Taiwan is a geopolitical flashpoint.
If China were to seize Taiwan, they would gain control of the factories that produce 90% of the world's advanced processors.
Why? Because without ASML's spare parts, software updates, and specialized engineers, the EUV machines inside TSMC...
Washington knows this. Beijing knows this. It is a technological poison pill. The threat of invasion is neutralized.
It is a deterrent carved into silicon, but it also means that the United States is desperately trying to duplicate this infrastructure on its own soil. Yet, building the concrete shells is the easy part. The bottleneck remains the same. You can build the most advanced clean rooms in the and there are not enough engineers on Earth to calibrate them all at once. The physical limits of light are now colliding with the human limits of training.
Which brings us to the ultimate boundary, the laws of physics. Where transistors shrink toward 1 nanometer, we enter the realm of quantum mechanics.
At this scale, electrons no longer behave like simple switches. They jump across barriers through...
To prevent this, chip makers are changing the shape of the transistors, wrapping the gate completely around the channel. We are trying to print structures that are only a few atoms wide, using light that must be focused with mirrors polished to the atomic level. If we fail, Moore's law dies.
And if Moore's law dies, the exponential growth of computing power that has defined the modern world for 60 years comes to an end.
We are running out of physics, and the only company holding the chisel to carve the next step is ASML. It is a heavy burden for a single board of directors.
If you look at the history of human progress, we have always relied on competition to drive innovation. But in the world of advanced semiconductors, competition is a luxury we can no longer afford. The cost is too high.
We have built a single global pipeline. A pipeline that starts in Germany with Zeiss mirrors, passes through America.
It is the most efficient supply chain in human history, and it is also the most brittle. It is a single glass tower built on a fault line.
What happens if the glass cracks? If a localized conflict, a natural disaster, or a political decision...
We have traded resilience for speed. We have built a world that is fast, smart, and incredibly fragile. And we are all living beneath its shadow.
Think about the device you are using to watch this video. The silicon inside it was printed by a machine that manipulated light in a vacuum.
You are holding a piece of this global dependency in your hand right now. It is a miracle, but it is also a warning.
If this journey beneath the surface has changed how you look at the technology around you, consider sharing this video. It helps us continue to reveal the hidden... And remember, the most important systems are always the ones you cannot see. The ones hidden behind corporate logos and national borders.
In our next episode, we will look at the invisible network that connects these silicon fabs to the rest of the world. The undersea cables, the physical threads of the internet.
And we will show you how easily they could be cut. Subscribe to stay informed. Because once you start looking beneath, you can never look at the world the same way again. Thank you for watching. And as we conclude this investigation, ask yourself, is the efficiency of a centralized world worth the risk of a single point of failure? We are already committed. We are already riding the light beam. There is no turning back. The future is being printed now, metrometer by metrometer, in a quiet suburb in the Netherlands. Keep looking beneath. We will see you in the next system, where we will examine the optical fiber cartels that control the data flow of entire continents. A system just as quiet, where we will examine the optical fiber cartels that control the data flow of entire continents. A system just as quiet. And just as fragile. Do not miss it.
and just as fragile. Do not miss it. The world is held together by threads. We are here to show you the scissors. The world is held together by threads. We are here to show you the scissors.
The Silicon Tower is high, but its foundation is narrow. Remember Veldhoven, the town that prints the future. The Silicon Tower is high, but its foundation is narrow. Remember Veldhoven, the town that prints the future.